All right, we're going to do a quick tutorial here about how to name compounds. There are millions and millions of compounds in the world, and no, this will not help you name every single one of them. However, especially when we talk about the ones that your body makes very complicated, builds chemicals of its own and stuff like that, and living things do that. But this will help you identify the majority of names that you will find on labels and stuff, and at least give you some idea how to hazard a guess what kind of things are in them. And so I think it's kind of a practical thing to do, and it will certainly help you with this. So let's start with metals and nonmetals. If you have something made out of two elements, one of them is a metal and one of them is a nonmetal. Let's just say start with NaCl, which is table salt. Okay, if we wanted to name that, the first thing we do is look at the first element, which is the metal. The metal always comes first when we write it. And so we would write the name of that. And Na is sodium. So we just put sodium. All right. Now, to show that the nonmetal is combined with that and not just chlorine, which is what it would normally be, Cl would be chlorine, we change it to IDE on the end. So instead of sodium chlorine, we have sodium chloride. Okay, and that's a good way to do that. So now basically sodium chloride, if we see that name, that tells us we have sodium and chlorine, but the chlorine is by itself. Okay, it's just chlorine and sodium hooked together. One other quick example, let's just do, let's see, magnesium fluoride. Okay, whoops, sorry, I already named it for you. But same thing, you have Mg, which is magnesium, F, which is fluorine. So same thing, it would be magnesium fluoride. All right, magnesium fluoride. All right, and so once again, the IDE on the ending tells us that anytime we see that, we know that we have two elements, magnesium and fluorine together. Now, slightly different, okay, is if you have a metal and a nonmetal plus oxygens. It says plus oxygen, but really it should be oxygens. Usually there's more than one oxygen. You'll see a lot of these. So, for example, say we have sodium and a PO4 on the end of it. This is phosphorus, this is oxygen. So sodium, which is a metal, and then we have two nonmetals stuck together, and phosphorus and oxygen. Okay, so the first thing we do is, once again, we name the metal. The metal is sodium. That's easy. All right, now P is phosphorus. All right, phosphorus. But if it were just sodium and phosphorus, that would be sodium phosphide. We put ID in it. To show that there's oxygen stuck onto it, we use the ending ATE. So, whereas this one over here was IDE, this one over here we're going to put ATE on the end of the word. And so instead of phosphorus, we're going to end up with phosphate. Okay. Other, for examples, let's see if we have MgNO3. Okay. We won't worry about the little numbers, but this would be basically magnesium again. And this one would be nitrogen, but now we're going to make that nitrate. Okay. And one last one just to finish off. This once again would be magnesium, but SO4 on the end is going to be sulfur, but with an 8 on the end of it. So instead of sulfur, we have sulfate. Okay. Now, if it was just MgS, that would be magnesium sulfide, because IDE tells you it's just two elements stuck together. 8 tells you it's a non-metal that's joined up with oxygen, and that's where the H's come from. Now, just for the record, sometimes you will see ites, like nitrites, which are in hot dogs, and I believe Oscar Mayer is trying to get all those out of their hot dogs now, because they can cause cancer and so forth, which they've known for a long time, but they're finally deciding to do something about it. So, magnesium nitrite would just be MgNO2. If there's one less oxygen, then it's ITE. Now someone says, well, how do you know if there's one less oxygen? Well, you'd have to know what the 8 was first, how many the 8 had in it. And I wouldn't really worry about that too much. I'm just saying, in case you see the word ite, all that means is it means like nitrite, phosphite, sulfite. That just means that it has one less oxygen than the nitrate or something. So it still gives you an idea of what it is. It's sulfur and oxygen, just one less oxygen. Okay, you don't see the ites very often. 8s are much more common. And so most of the time you'll see phosphate, nitrate, carbonate, sulfate, whatever, and so on like that. All right, last you have metal and hydroxide. Let's say the next one. Let's say we have a metal. Let's say sodium again. And we have OH. Okay, OH is called a hydroxide ion. Okay, or sometimes you will hear it called a hydroxyl ion. But either way, same thing. Hydrox, hydrogen, oxygen. So it has hydrogen and oxygen together. And so that's going to be OH. So we would just put sodium, once again, hydroxide. All right. Magnesium hydroxide. You could have potassium hydroxide, whatever. But whatever the name of the metal is, and then you just put hydroxide here. These are what we call bases. We'll talk about those when we talk about acids and bases later. But hydroxide is just the OH. Anytime you see the OH, like here you have OH, that's hydroxide ion or hydroxyl ion. So it's going to be sodium hydroxide or potassium hydroxide or whatever. All right. Now the last thing is nonmetals. When you have two nonmetals stuck together, and someone says, well, how can you do that? Because metals are positive and nonmetals are negative, and yeah, you can see how those stick together. Nonmetals share electrons with each other, and because they're sharing the same electrons, that sticks them together also. And so, for example, if you have CO2, okay, it's very similar. You still write the name of the first one, carbon, but now for the second one, it would be IDE because there's two elements there. So, okay, ide, oxide, but since there's two of them, you would call it carbon dioxide. All right. If you had a CO3, you could call it carbon trioxide, which as far as I know, there's not such a thing. But for example, CO is carbon monoxide, or carbon monoxide. We talk about carbon monoxide poisoning, and mono means one, so basically it means there's carbon with one oxygen. Okay. Just a record, if you had H2S, you could do it with the first one. If it has more than one, we're going to call this dihydrogen sulfide. Remember, we said hydrogen can act kind of like as a nonmetal. So in this case, it's named like that. Dihydrogen, there's two hydrogens, and then sulfide because the sulfur is just one. Okay, if there were H2S2, then it would be dihydrogen disulfide, possibly. Okay, and so generally that's how it works. If you see di in front of a word, tri, mono, and so forth. You could see tetra. There's such a thing as tetrachloride, which means four. Okay. But usually it's going to be mono, di, and tri is the most common ones that you'll see. But you may see a tetra and so forth. Okay, for the record, dihydrogen sulfide is basically rotten egg smell. So there you go. All right. And there are going to become chemicals that's just the way they are. They're named things like water. Water is water. Okay. So if people see H2O, they're not going to say it's dihydrogen oxide, which technically it could be considered dihydrogen oxide. That's a good name for it, but we're just going to call it water because that's what it is. Okay, everybody knows it is that, and there are certain chemicals like that. There are some that were named weird ways long time ago. I mean, you will see NaHCO3, which this is sodium, this is carbonate, and there's an H. So you'd think it'd be called sodium hydrogen hydrogen carbonate, but actually it's called sodium bicarbonate. And there's a lot of things that have that. An H in the middle is called bi. Why? There was a reason they did that originally, and it's been so long ago, no one changed it. It's just sodium bicarbonate, and that's what it is. Although, if you called it sodium hydrogen carbonate, someone would know what you're talking about. As the chemist would know what you're talking about, and so forth. Okay, so there are some that just have weird names because they were given weird names, and everybody accepted that before they came up with the system of how we're going to name them. And rather than fight years of tradition and what people knew it as, they just said, we'll just let that one violate the rules and be done with it. Okay, and there's going to be some of those as well. But these are basically some rules that will allow you to name many chemical names, especially ones that are not from living things, that are just not put together by living things. Because living things can make very complicated names and very complicated chemicals. But this will help you identify or at least narrow down what chemicals are in a substance in the majority of cases. So it also enable you to do the How to Name Compounds worksheet, which is very important since you will need to do that by the time we meet. And we'll go over that on Thursday.